the acids are anything below 7. And so I draw my box above 7. A little confusing there. But any number, any pH less than 7 is an acidic solution. Any pH above 7 is an alkaline solution, or basic solution. So a pH of 6, you got okay? I can't see it. Yeah. It's not great, is it? Now we already did the basics, so those had more hydroxide ions than hydrogen ions. So we're doing the acids now. Are they going to have more hydrogen ions? Yes? They'll have more hydrogen ions than hydroxide ions. So pH of 6 has more, being used to this notation, hydrogen ions than hydroxide ions. How many more? Pattern? 10 times more. And then if we go up to a pH of 7, there would be, oh wait, no, I didn't do that. If we go down to a pH of 5, there will be 100 times more hydrogen ions. So coffee has 100, no, look at that. Coffee has 100 times more hydrogen ions than hydroxide ions. So when you're drinking your coffee, it's a little bit acidic, and you're getting a pretty good dose of hydrogen ions there. Tomato juice is even more acidic. 4. Beer and wine can be as acidic as 3. Now that varies a little bit. Depends what brand of beer and what type of wine. But if you have a pH of 3, how many more hydrogen ions are there than hydroxide ions? 10,000. You've got 4 zeros after the 1. So pH of 3 would have 10,000 more hydrogen ions than hydroxide ions. For those of you that want to see me do the math here, urine would be 10, black coffee would be 100 times, tomato juice would be 1,000, and then beer would be 10,000. I got that? Now, considering that we probably drink, probably not necessarily tomato juice a lot, or even not, some of you probably don't drink coffee, but I do. Because I'm drinking these acidic things, how do I keep my blood's pH near 7? How does the body do that? We're absorbing these acids and even sometimes bases in our food. What does it have in our blood that helps maintain that pH at 7.3? Buffers. Is that what I heard? Buffers. Buffers. Correct. We have buffers in our blood, and actually in all of our tissues and fluids. And buffers maintain a stable pH even with an introduction of acids and bases. I got a long head. That's an eye, I can tell. So buffers maintain a stable pH even with an introduction of acids and bases. And I'm going backwards on my board. They do this by releasing or binding excess ions. No, pick out that word back to us. So releasing or binding extra ions or ions in general. In which case they can either bind on to extra hydrogen ions that come in, or they can release them if that'll help adjust the pH. And the same with hydroxide ions. So on the next page in your book, this is in smart board. On page 29, this buffer that they talk about in your book, the bicarbonate buffer, is the exact buffer that maintains your blood pH. And so everybody can read that for you, all right? What can happen is it can manage the blood pH whether there's an influx of OH ions or hydrogen ions. And so if OH ions come in, the molecule carbonic acid will pick up the OH and also produce water from the oxygen and the hydrogen atoms coming in. And when it becomes, the carbonate becomes bicarbonate and water. And so that's going to keep that pH at 7. If you have an influx of hydrogen ions, it'll go back the other way. Bicarbonate will pick up the hydrogen ions, so it's not floating loose in the solution anymore, and will become carbonic acid. Either way, what goes away are these ions that are what affect the pH. And so they won't be in the solution to cause the solution, in this case, to become alkaline, or in this case, to become acidic.
Baking soda is pretty.
It is. So baking soda is a pretty good buffer. So that's a quick introduction to buffers. Questions about that? And it's time for our second in-class writing. You guys are looking drowsy. Actually, it's going to be a short one. I just want you to compare the pH, and I like your book figured out of hair remover to, let's say, typical rainwater. And what I want you to do with that, identify which one's more acidic and which one's more basic. And then also compare how much, or the difference between the proportion of the hydrogen ions and the hydroxide ions. So rainwater and hair remover. Compare the two, so figure out which one's acidic, which one's basic, and then the proportion of hydrogen and hydroxide.
Alright, next one.